Hello my dear students, welcome to my channel Chemistry with ASR. Okay, I can see Abhishek. Hi Abhi. Okay, so in today's session, we're going to discuss about the classification of hydrocarbons. We're going to discuss about the classification of hydrocarbons. Now before that, what are hydrocarbons? Hydrocarbons, the simplest organic compounds containing only carbon and hydrogen, are called hydrocarbons. Now there is something called as a parent hydrocarbon. Now what is this parent hydrocarbon? Whenever you see only carbon atom and carbon atom attached to hydrogen atoms, linked to hydrogen atoms, then I call it as hydrocarbons. What are they? Hydrocarbons. And these hydrocarbons are called as the parent hydrocarbons or parent compounds. Suppose I replace one or more hydrogen atoms with heteroatoms, one or more hydrogen atoms with heteroatoms, then I call them as derived compounds. So these derived compounds are obtained by replacement of one or more hydrogen atoms. Now the question is, why do we have to classify these compounds? Why do we have to classify these compounds? Is respond in the chat box. Why do we have to classify these organic compounds? Yes, as we advance in the subject, the number of organic compounds become large. Okay, and due to which it becomes very inconvenient to study the chemical behavior of the compounds individually. If I have to study them individually, it becomes extremely difficult. So for that purpose, I have to classify these organic compounds. So therefore, these organic compounds are simplified and studied systematically by classifying them broadly into two types. What are those two types? One, the cyclic or closed chain ring. Another one, acyclic or open chain compounds. So first one is acyclic or open chain compounds, and these are also known as aliphatic compounds. So what are these aliphatic compounds? These are obtained from the animal or vegetable oil. Aliphatose means fat. So that's how the name of the compounds are derived. Okay. Now this acyclic or open chain or aliphatic compounds are those which contain open chains of carbon atoms. So it can be either straight chain or branched. It can be straight chain or it can be branched. Okay. Now what are the examples of straight chain hydrocarbons? CH3, CH3. This is a straight chain, right? That's nothing but your ethane. CH3, CH3 is nothing but your ethane. Next one is isobutane. Here is the example for it. Isobutane. Yes, isobutane, CH3, CH, CH3, CH3. So it comes under the category of branched. All right, children. Next, we have other examples also, like an aldehyde and carboxylic acid. So it is CH3, C double bond O, H. This is acetaldehyde. And there is another compound called as acetic acid, which is CH3, C double bond O, OH. I hope this is clear. So what did we learn till now? Organic compounds are classified into two types. One is acyclic, another one is cyclic. Under acyclic, we have straight chain hydrocarbons or branched chain compounds. Now these straight chain compounds have the examples as ethane and many. It can go up to many number of carbon atoms. Branched chain compounds are examples for them are isobutane. So these are the examples. All right. Now let us move on to the next type, that is cyclic or closed chain compounds. It is also called as ring compounds. Here, one or more closed chains or rings of atoms in their molecules are seen. So one or more rings. One or more rings in their molecules. Further, they are classified into two types. One is homocyclic and other one is heterocyclic. The homocyclic is also known as carbocyclic. Okay. So the compounds are further classified into alicyclic and aromatic. Okay. And these alicyclic compounds are classified into heterocyclic, homocyclic, which is known as carbocyclic. Homo means what? Homo means the molecules with only one type of atoms in their rings. Okay? Only one type of atoms. So for example, you have only carbon, skeletal structure is only carbon in case of benzene. Then I call it as homocyclic. You have a cyclopropane. Can you see here? Cyclopropane with 3 carbon atoms. It is closed structure. It is ring and it is carbocyclic or homocyclic. Next one is cyclohexane. Cyclohexane. All these can be saturated or unsaturated. So this is cyclohexane. Then I have another example for you. It is called as cyclohexene, which is unsaturated. So in the last session, I had told you what is saturated and unsaturated. If there are no double bonds, if there are only single bonds, then I call it as saturated compound. If there is at least one double bond or at least one triple bond, then I call it as unsaturated. Next one is heterocyclic compounds. Heterocyclic compound is nothing but in the ring there should be at least one hetero atom. So for example, I have tetrahydrofuran. Its structure is how many carbon atoms are there? 1, 2, 3, 4. 4 carbon atoms are there and there is one oxygen. Within the ring, here what you saw, all the corners are only with carbon atoms. So it is called as carbocyclic. Whereas here it is heterocyclic. Within the molecule, within the ring, there is one heteroatom. It can be oxygen, sulfur, nitrogen. Alright? Yes. Next one is aromatic hydrocarbons or aromatic compounds. Now what are these aromatic compounds? Aromatic compounds are very special type of compounds. Okay, you learn about this more in the next unit. But as of now, what are these aromatic compounds? These are compounds which have a special characteristics. Okay, and these aromatic hydrocarbons or aromatic compounds are classified further into benzenoid, non-benzenoid, and heterocyclic aromatic compounds. What are they? Benzenoid, non-benzenoid, and heterocyclic aromatic compounds. So in case of benzenoid, we have an example of very classic example that's called as benzene. So what is the structure of benzene? It is a six-membered ring with alternative single and double bond. It is a conjugated compound, meaning to say there is a presence of alternative single and double bond. It has a special property. Alright. Then there is another example called as aniline. Aniline has one benzene ring. To this benzene ring, one NH2 group is attached. There is another example, that is naphthalene. Naphthalene has two benzene rings. You can't see anything else apart from benzene rings in these type of benzenoid compounds. Further, you have anthracene. So many such compounds are seen. So what did you observe? I wrote the double bonds and single bonds. They are in the alternative ways. Next one is non-benzenoid. It is aromatic compound, but it does not have a benzene ring. So in such case, I have one example. It's called propone. So let me draw the structure here. Propone has C double bond O. Okay. So you can see that there are double bonds. Okay. So this is also an aromatic compound. And next one is heterocyclic aromatic compounds. So for this, so this is propone, right? Okay. Next one. For this, there are examples like furan, thiophene, pyridine. So let me draw the structures of it. Furan. I have one oxygen atom in the 5-membered ring, right? Thiophene. Thio means something related to sulfur. I have sulfur in the 5-membered ring and there is a double bond. And the last one is pyridine. So pyridine is a 6-membered ring. One atom has nitrogen within the ring. So this is a pyridine and you have double bonds. So much is clear. These organic compounds are further classified based on their functional groups. that we shall study in the next session. So as of now, I hope this classification is clear to you all. Quickly, organic compounds are classified into cyclic and acyclic. Acyclic compounds classified into straight chain, branched. Cyclic compounds are further divided into alicyclic, aromatic. Alicyclic is further divided into heterocyclic, homocyclic. Aromatic compounds are further divided into benzenoid, non-benzenoid, and heterocyclic aromatic compounds. So this is about the classification of organic compounds. I hope this is clear, children. If you have any doubts, now you can write on the chat box. Okay, good response. Yes, benzene rings. Amine NH2 group attached to the benzene is called as aniline. All right. Okay, then we shall wind up the session now and meet you in the next session.